Sparkle's Voyager mission into interstellar space and beyond. When we left off, Voyager 1 was venturing into the deepest reaches of space. After decades of traveling farther than any object humanity has ever sent, the spacecraft was approaching a mysterious region known as the heliopause, the boundary between our solar system and interstellar space. Scientists expected this transition to be sudden and dramatic. It was believed that once the spacecraft left the heliosphere, the protective bubble created by the sun's solar wind, it would encounter a vastly different environment. They anticipated higher levels of cosmic rays, intense bursts of charged particles, and a shift in the direction of the magnetic field. However, what Voyager 1 encountered wasn't exactly what scientists predicted. Test tube the heliosphere's hidden complexity. On August 25, 2012, Voyager 1 finally crossed the heliopause, becoming the first spacecraft to officially enter interstellar space. The spacecraft detected a noticeable rise in plasma density, confirming it had passed beyond the influence of the sun's charged particles. But strangely, it didn't detect a clear change in the direction of the magnetic field, a finding that puzzled researchers. This raised new questions. Is the transition between solar space and interstellar space more gradual than we thought? Is there a kind of magnetic blending at the edge of our solar system? Voyager's data has led scientists to rethink their models of the heliosphere. Far from being a smooth, spherical bubble, the sun's influence may be irregular, shaped by both solar activity and nearby interstellar winds. Milky Way mapping the unknown. Voyager 1 is now exploring a region called the local interstellar medium, filled with ionized gas, dust, and cosmic radiation ejected from exploding stars' supernovae millions of years ago. Even though it travels at about 17 kilometers per second, it would still take more than 40,000 years for Voyager 1 to reach the next closest star system. Yet, every bit of data it sends back helps scientists study the boundaries of solar influence, the shape of the galactic environment, and the nature of the space between stars. Meanwhile, Voyager 2, which followed a different path, also crossed into interstellar space in 2018, confirming many of Voyager 1's findings but also revealing new mysteries. Wrench, a mission running on fumes. Keeping these spacecraft running is no small feat. Both Voyagers are powered by radioisotope thermoelectric generators, RTGs, devices that convert heat from decaying plutonium into electricity. But after decades in space, the power they produce has dwindled. Each year, NASA's team has had to make tough decisions about which instruments to keep running and which to turn off. The team has also dealt with software glitches, weakening signals, and aging hardware that was never meant to last this long. Yet despite all this, the Voyagers continue. They are now more than 45 years into a mission that was supposed to last just 4. Shooting star. Humanity's quiet triumph. The story of Voyager isn't just about technology, it's about human determination. It's about building something that endures, and daring to send it into the unknown without knowing what it might find. Each piece of data they send home offers new insight into the universe, from the farthest frontiers of space. Eventually, the Voyagers will go silent. Their signals will fade. But their journey will continue. They will drift through the galaxy for millions, perhaps billions of years, long after Earth itself has changed. Each Voyager carries a golden record, bearing a message from humanity, a small whisper across the stars, saying, "We were here." What do you think Voyager's discoveries mean for us here on Earth? Could they help us understand how to leave the solar system, or how to protect it? Let us know in the comments, and if you were inspired by this journey, like this video and subscribe. Milky Way Voyager mission. Humanity's most daring journey begins. The farthest human-made object from Earth isn't a satellite orbiting a planet, or a telescope looking into deep space. It's a small spacecraft called Voyager 1, built by NASA. Launched in 1977, this remarkable machine has continued its mission for over 45 years, venturing into regions of space no spacecraft has ever gone before. Voyager 1 has now reached interstellar space, the area beyond the influence of our sun's solar wind, a true cosmic milestone. What makes this even more astonishing is that Voyager 1 is still in contact with Earth, sending back valuable data from over 14 billion kilometers away. It's running on technology that predates compact discs, smartphones, or even home computers. The spacecraft contains only 69 kilobytes of memory, far less than the smallest app on your phone, and its signals are transmitted using just 23 watts of power, roughly the same as a small household light bulb. Even so, this humble spacecraft, built during the era of 8 tracks and rotary phones, continues to rewrite the history of space exploration. Globe, a brilliant idea from Earth. The story of Voyager's mission begins with a stroke of genius in the 1960s, when a NASA engineer named Gary Flandreau, working at the Jet Propulsion Laboratory, made a stunning discovery. While studying planetary movements, Flandreau realized that a rare alignment of the outer planets Jupiter, Saturn, Uranus, and Neptune was going to occur in the late 1970s. This planetary lineup only happens once every 176 years. The unique gravitational configuration would allow a spacecraft to use a series of gravity assists, slingshotting from one planet to another to dramatically reduce travel time. Without these assists, it would take a spacecraft about 30 years to reach Neptune. With them, the journey could be completed in just 12 years. NASA knew this opportunity wouldn't come again for generations. So in 1977, just 15 days apart, they launched Voyager 2 and Voyager 1, 2 identical spacecraft built to explore the outer solar system. The plan was for Voyager 1 to head toward Jupiter and Saturn, while Voyager 2 would continue onward to Uranus and Neptune. Rocket a mission that outgrew its plans initially. The Voyager program was only meant to last 4 years, long enough to explore the gas giants. But from the very start, both spacecraft exceeded expectations. They sent back breathtaking images of the moons of Jupiter and Saturn, revealing volcanic eruptions, icy terrains, and complex weather systems. What we once thought were cold, dead worlds turned out to be dynamic and active worlds with geological activity and, in some cases, possible subsurface oceans. Voyager 2, which traveled a slightly different path, became the first and only spacecraft to fly by Uranus and Neptune. In 1986 and 1989, it sent back images of their moons, rings, and magnetic fields, giving scientists entirely new perspectives on the most distant planets in our solar system. All of this was accomplished using 1970s technology. The Voyagers didn't have digital cameras or modern processors. Instead, they used analog tape recorders to store data, and 12-foot satellite dishes to transmit their findings back to Earth. Each signal had to travel for hours today. A message from Voyager 1 takes over 22 hours to reach Earth. And yet, we're still receiving valuable data. Brain artificial intelligence of the 1970s. What's truly incredible is how autonomous the Voyager spacecraft had to be. With limited processing power and no real-time guidance from Earth, their onboard computers had to make real decisions during their journey, like adjusting instruments, managing data collection, and protecting themselves from cosmic radiation or unexpected system glitches. This early form of artificial intelligence allowed the spacecraft to survive cosmic hazards, such as the asteroid belt, and navigate some of the most dangerous environments in our solar system. In fact, the Voyagers were only the second set of spacecraft, after Pioneer 10 and 11, to cross the asteroid belt, a region once thought to be impossible to survive. Shooting Star, the first interstellar messengers. As Voyager 1 continued outward, its mission gradually shifted from planetary exploration to interstellar discovery. It became not just a robotic explorer, but humanity's first ambassador to the stars. Each Voyager probe carries a golden record, a 12-inch gold-plated copper disc containing sounds, music, and images from Earth. These records were designed as a time capsule, meant for any intelligent life that might someday discover the spacecraft. Even if the Voyagers go silent, their golden records may continue drifting through space for billions of years, carrying greetings in 55 languages, whale songs, and even chuckberries,